Hello, everyone, and welcome. Thank you all for joining us today for the last webinar in Sustainable Conservation's People, Place, and Policy series, A Scott River Restoration Story. Before we get started, I'd like to give many thanks to our webinar sponsors, Spotswood Estate Vineyard and Winery, Wilson Sonsini Foundation, Environmental Science Associates, and Holland and Knight for supporting our webinars and sharing sustainable conservation's vision of a climate-resilient California. I'm Stephanie Falzone, Senior Project Manager on Sustainable Conservation's Accelerating Restoration team. In our fall webinar series, Sustainable Conservation and our guests have been exploring the important connections between people, place, and policy that drive lasting impact for our shared climate and water challenges. Today, I'm honored to have as panelists staff from the Yurok Tribe and California Trout to discuss how different interests can work together to deliver solutions that benefit both fisheries and working landscapes, serving as a model for bringing diverse groups together to solve complex problems locally and in other areas of California. If you have questions at any time for our panelists during this webinar, please put them in the Q&A box, and we've saved some time at the end for audience questions. But before I introduce our panelists, I'd like to poll all of you, our audience. There are 3 poll questions, so be sure to scroll down to answer all 3, and if you don't see your answer reflected, feel free to type it in the chat. So we'll give a couple minutes for people to answer the poll. First question is where you're located. Seeing a good amount of folks from the Bay Area. That is also where I'm located. And we've got some Northern California coast and inland. Some folks from out of state and other. Both affiliation, good amount from government and agency. We've got quite, covered across the board. And then a level of knowledge about habitat restoration, pretty kind of, standard distribution. So yeah, all kinds of levels of knowledge, which is great. Okay. So we'll go now to our people and learn more about our panelists. Travis James works for the Yurok Tribe as a senior civil engineer, design and implementation branch manager. So Travis, tell us a little bit about yourself, how you got into this kind of work and what you do for the Yurok Tribe.
Thank you everyone for joining us today. Thanks Stephanie for the introduction. Yeah, I'm the senior civil engineer. I've been with the Yurok Tribe for a little over 2 years. And I came on when the Scott River project was sort of just coming up into what we ended up constructing this summer and really getting going. I've been in the restoration world for about 17 years in the private sector before coming over to the tribe, and I've worked in all sorts of facets from hardscape concrete structures to natural river restoration projects. So kind of the whole broad range of restoration.
Awesome. Thanks for joining us today. And Leslie Hubbard oversees the Environmental Compliance and Grant Development Branch of the Yurok Tribe Fisheries Department's Design and Technical Services Program. So Leslie, tell us a bit about yourself and the work that you do.
Good morning, Stephanie and everybody else. So yes, I oversee our Environmental Compliance and Grant Development Branch. Our program, Travis and I work for the same program under the Fisheries Department of the Yurok Tribe. We specialize in in-stream restoration, mostly off of the Yurok Tribe's reservation. We are getting more interested in getting outside of just strictly in-stream restoration as well, just for ecosystem restoration. I've been with the tribe for about 5 years and have background in biology, and it seems like the environmental compliance part is just necessary for anything we want to do. Started getting involved in that, and then that is pretty much what I do full time.
Thanks, Leslie. And our next panelist, Dustin Revelle, is the Mount Shasta Klamath Senior Project Manager at California Trout, also known as Cal Trout. So Dustin, tell us a bit about yourself and what you do at Cal Trout.
Yeah, so I have a background in engineering. Out of college, I got a job as a civil project engineer, and then did that for a few years. Ultimately, decided I didn't want to go down the road of, just civil development. I took a break and became a fishing guide for a few years, and then got a job at Cal Trout, which kind of combined both my interests. I've always been really interested in fisheries related issues, and also have a kind of a technical background, so it combined that really well. And with CalTrout, we identify problems and develop projects to address those problems. My time is kind of split between doing actual like habitat restoration projects as well as more, farm agricultural related flow enhancement projects.
Well, we're so lucky to have you all here to talk about this project. So now we met our people. Let's talk about the place where this project is being implemented. So if you all could talk about where is the Scott River? Why is it so important for fish and for people? And why does it need restoration? And I know you have some visuals, so we'll give you a second to get
Yeah.
those queued up.
Yes, thank you. And we're going to try to put this through as a more casual discussion, but we do have slides to not only help support what we're talking about, but show the project site so that it really it's more descriptive. And
Yeah, there's a
uh,
lot of different aspects of the project here that are kind of hard to just give a quick overview of. So having the images are really important for this.
yes, great. So we're working in, and we're going to bounce around a little bit who's talking, but we're working in the Scott River, which for those who don't know is in Northern California, east or west of I-5, which you can see I-5 here going by Mount Shasta in the Scott Valley. Here's Etna, California, and there's another small town called Callahan, California that didn't show up on this map. And we're in what's referred to as the tailing reach. It extends, it's around 4 miles long. And our project location for this, for the project we're discussing today is in this footprint here. And we'll get into more of the details as we go forward. Here is a drone footage looking downstream from the downstream end of this year's construction project. In the foreground, we have Moore's gravel operation where they take material from the tailings themselves, sort it, and then it becomes a product that they sell. And in the further off in this photo here, you can see those tailing piles. And Dustin's going to touch on, the dredging aspects that created these in a moment. But you can see the river corridor is really tucked up all the way to the east side. So we're looking north here. And that became part of the problems that we're looking at solving. This is an image looking upstream from the upstream end of our project, and you really get a sense of the scale of the tailings reach. Again, the channel is tucked way off to the east side here, and this water bodies you can see in the middle are different pond configurations that were a result of where the dredge may be turned or past additional mining operations to collect gravel and potentially other materials. Dustin, you want to talk about the bridge?
Yeah, sure. So when you look at that site, I mean, the first thing that's really apparent to you is the mine tailings. It's the most obvious impairment in this reach. There were at least three dredges that operated in the vicinity of this project site, and you can see images of those three dredges here. The first one was the upper right dredge that was operational by at least 1905. The second dredge is that upper left, and that was operational by 1908. And then the bottom left is the dredge that did most of this damage that you see, and that was, I think, 1928, if I remember correctly. Um, and the first two dredges were fairly limited by material and technological limitations, particularly with like welded steel. And they were made primarily out of wood timber framing. And that combined with the characteristics of the substrate, um, the first two were mostly failures. However, a man that was involved with the design and operation of the second dredge went on to found Yuba Consolidated Goldfields, which is probably the largest dredge manufacturer in the world ever. And he purpose-built this dredge, the third dredge, for this site, noting the failures of the second dredge, which they described as encountering, very, very little fine material and highly cemented substrate, which is that cementation process is a result of microbials, basically uriatic bacteria precipitating calcite and other things that will cement the substrate together and reducing the overall permeability. So basically, when they dredged it and they literally scooped up every piece of sediment above the bedrock layer and then restacked it, the combination of the characteristics of the substrate and the design of the dredge led to an extremely well sorted tailings pile with all the fine materials being deposited at the very bottom in a relatively thin layer, with all the cobble being stacked on top of that. So it resulted in a really kind of unique tailings and very highly permeable. And Travis, go ahead and keep her moving here.
Yeah, so here's an aerial image of the tailings reach flows going from right to left. And you can see the Scott River sort of tucked up here on the top of the river corridor with all the tailings downstream of Moore's. Here's the Moore's gravel operation. Here's past operations, and then some other smaller ponds that are scattered throughout these tailings. Our project's footprint is in this area here. And one of the things that, that permeability that Dustin just referred to, now the impact of that on not only fish, but also people, is that it draws down the groundwater surface through this reach. And this profile on the bottom of the image here, this brown line is sort of the thalweg following this stationing up here. And these little blue squares indicate the water surface elevation of these ponds superimposed onto that profile. And if you look closely, you can see that a lot of these ponds are quite a bit below the actual elevation of the channel. So as flows start to recede into the drier parts of the year, the water has a tendency to go subsurface to go to that groundwater, and then really moves quickly through the tailings reach. And one thing that it's really interesting to look at is these downstream ponds where, down here is sort of an undisturbed ground system. That flow that's easily moving through the tailings runs into this, and you can see pond 28 and 27 are actually perched above the channel. And going through historical imagery, you can see that this is where the channel often re-wets when a lot of this area is dried out. And if you look at this black line here, we're going to look at a cross section through, and I think it really points home sort of this discussion of using the pond's water surface elevation as a surrogate for groundwater, which I think is a pretty strong argument. You can see that water surface is way down here, sometimes 8 to 11 feet below where the Scott River itself is. So water from the channel moves relatively easy through these remnant tailing piles and then can move downstream through the groundwater system, leaving the Scott River itself dry. So we're going to look at some of the project components, and I'm going to go up to this map again real quick and just talk about a couple of features that'll come up throughout. Our project, again, is in this orange, and we have Sugar Creek, which is an incredibly important tributary to the Scott River, and then the Scott River itself. And we'll talk about some of the features of the two water systems as we move forward.
And just real quick, I want to add in that the Scott River is home to one of the largest populations of the Southern Oregon, Northern California coho evolutionary significant unit, making it a very high priority for recovery of that threatened species.
Yeah,
Yeah, thanks for showing that. I mean, it really just it's hard to get a sense of the impact of all that dredging and how it's, altered this waterway so much and how it alters how water moves through that system. So yeah, the visuals are really helpful.
yeah, thank you. So I feel like the slide got out of order here, but we'll go with it. So what we're looking at here is Sugar Creek, and this is one of the interesting facets of this project. And this is where it truly is a, a gathering of a whole bunch of different groups coming into a project and trying to move it forward, knowing that, there's going to be trade-offs and trying to figure out how we work together, from the farm side, from the fisheries side. And what we're looking at here on screen is Sugar Creek had a really well maintained beaver dam analog systems that a lot of individuals probably on this call have visited or heard about. And because of some of the impacts because of going all the way back to the dredging and some of the changes happening in the Scott River, if these BDAs weren't in place, I think coming up with solutions to help stabilize the channel would be really important. And you'll see in a moment what we did for that and its impact on these BDAs, and then some of the elements we tried to impose to help mitigate some of those measures. And for the Sugar Creek profile in particular, here's Scott River itself. And the Scott River has been incising over time, and Sugar Creek has been reacting and trying to incise. And some of the BDAs were helping arrest that head cut, but there is always the potential that these BDAs fail and a head cut moves upstream, which could impact the groundwater system and a lot of other not infrastructure, but improvement projects that have been completed by the Scott River Watershed Council, which has done an amazing job on their projects. So there was these trade-offs, and we'll get to some of those as we move forward.
And then for those in our audience who may not know, can you explain what it means when it's the channel's incising and like what a head cut is
Yeah,
and why that's a problem?
yeah. Thank you for reminding me that some people might not know those terms. So incising, basically the water's energy is cutting down. So it's taking the elevation that the channel was here and it's moving material out and not being replaced. So the channel is down cutting. And a head cut is just basically that where that down cutting is starting, that is kind of where that head cut begins, or nick point is another term for it. Dustin, you want to talk about Farmers Ditch Company and their important role in this whole project?
Yeah, so just a little background on the Farmers Ditch Company. It's a group of 9 family-owned ranches with a shared conveyance system. In aggregate, they have 30 CFS water right with a 6 CFS surplus, and they've been in operation since the 1880s. So it's a historic ditch, and it's changed. It's been reconfigured a few different times, but a lot of the ditch itself is in the same alignment that it's been for nearly 150 years. Let's go ahead and go to the next slide here. It's a 12.5 mile long, low gradient earthen ditch, and it follows the valley's eastern edge. It's gravity driven with no pumps, completely passive, and it irrigates the fields in between the ditch line and the Scott River. The photo in the map was taken during the drought. That was, in most years, is a lot more green pasture, and they irrigate a mix of pasture and for grazing cattle and also for hay production, alfalfa, and grass pasture. Let's go to the next slide. Yeah, so to really understand the reason this project is needed, I think let's take a second to go over kind of the layout here. So the Scott River comes in from the upper right on this map. Yep. And we have Sugar Creek coming in from the lower right. And then there's an island split right there. And at least in its current configuration, the flow favors that river right side of the island, the red line. And then, so upstream of the island, there's a little green diamond, and that was the existing point of diversion for Farmer's Ditch. And then they had, so then they had a length of their conveyance system below the point diversion before they had a fish screen. So there was a section of their conveyance system that was open for fish to enter, which is not a great situation because it leads to stranding annually, sometimes several times per year. There's a bypass system, but it's really not that well configured. They call it a fish bypass. So basically, you have some amount of water in the ditch that allows fish that enter the ditch to leave the ditch through a bypass pipe that re-enters the river. However, the functionality of that is very questionable. For a large portion of the year, the bypass kind of flows out onto a dry riverbed. So yeah, not a great situation. And this fish protection component is a major impetus of this project. Okay, let's see. Travis, did I get everything there? Oh, wait. Yeah. So
Yeah.
one more thing here about the Sugar Creek interface. Because this material is so permeable, the riverbed itself, and the configuration of the island that the flow favors the right side, and the diversion and the bypass within the diversion, very little water actually flows on that left side during base flow conditions. And it is often flowing subsurface, both upstream and downstream of the Sugar Creek confluence, which really leads to an isolating condition for Sugar Creek. Fish can't enter, they can't move upstream, downstream. And that is also a primary driver of this project, is getting that connection between Sugar Creek and the Scott River in a way, to provide passage, particularly in the upstream direction to the headwaters.
Yeah, I think
Nice.
that
Yeah, I
covers
remember.
it. Go ahead.
Yeah. I remember some time ago, someone reminded me that, flow is also fish passage. That seems like a big part of this project.
Mhm.
So yeah, let's talk, this is a complicated area. There's a lot of things going on. Let's talk about, this project and what it's designed to do and what benefits it's expected to provide for the Salmonids, the lamprey, tribes, local ranches, community.
Before we touch on that, Stephanie, can we touch on sort of the project partnership?
Oh
and things?
yeah, sorry.
Yeah.
Yes, I got excited about the benefits of
Okay.
this project. So yeah, what are, there's a lot you're gonna do, but how did you get here? It took some things, this memorandum of understanding. So yeah, let's talk about how we even got to doing this project.
Yeah, no problem. And I realized we should probably speed up a hair bit, so we'll go over these relatively quickly. The most important component of getting this project up and off the ground was a memorandum of understanding entered into by Farmers Ditch Company, Yurok Tribe, and California Trout. This predates me coming to the tribe, and I believe predates Dustin coming to Cal Trout. So we weren't there at the beginning, but some people may think these entities wouldn't normally come together to have a successful project. And here we are, and I do think we ended up with a successful project, and I'm hoping it's just the beginning of continuing to try to work in the tailing reach, and then expanding that out to other groups in the area as well. And very quickly, project team, the leaders of the project was YTF, that's Yurok Tribe Fisheries, Cal Trout, and Farmers Ditch Company. YTF, we oversaw the in-channel design, while the point of diversion was really led by Dustin and Cal Trout and Cascade Stream Solutions. For those who maybe know Joey Howard, that's Joey Howard. And permitting was led by YTF with a lot of support from Cal Trout and the Scott River Water Trust. The Water Trust is another organization in the Scott River Valley. Construction was overseen by the Yurok Tribal Construction Corporation. For those not familiar, basically YTCC is, think of it as a private contractor that is both licensed to the Yurok tribal government and through the state of California. And then Yurok Tribe Fisheries, my team was out there a lot, and I should note that Scott River Water Trust was out there a lot. Cal Trout, Dustin was out there a lot. This was definitely a group effort, and you'll see why in a moment. And some of the monitoring that we're beginning now, you can see those partners who are going to be working on that. The other part of this project, this is the people component, is these other interested parties, and we have the Callahan family who. They're adjacent to the project, and actually the Farmer's Ditch pointed diversion was on their property, and they wanted it moved. So working with that family, it was a big part of this project. The Watershed Council, I've mentioned them a couple of times, an important restoration organization working in the valley, both immediately adjacent to where this project was, as well as other locations throughout the valley and probably beyond. And they are an adjacent landowner. Mike Calpine, he's an adjacent landowner. He owned the property that the Watershed Council now has, and is the current leasee of that property. So, working with that gentleman. And then you've seen some of the Moore's Gravel, an adjacent landowner, and hopefully a willing participant in next phases of design and construction. And an important part for receiving material, we purchased a lot of material to help build our project. The Gentry family, not involved directly in this one, but was an interested part of the local landowner group. And this group in particular became known kind of sort of as the core landowner group. And it was such a neat thing to work with this group, where basically if one of them wasn't happy, then we needed to adjust the project to try to get it so that we found balance, and that takes trade-offs and making things work. And then of course there was other landowners just outside that periphery, and that kind of is sort of the who and how we got this whole together.
Yeah. A lot of different people involved in making these projects happen and to coordinate with. That is something we see with a lot of restoration projects. So now, we're ready to talk about, I got too excited to talk about the benefits, but I think we're ready to talk about that now.
Yeah, so we're gonna walk through the project, and I'll ask Dustin and Leslie to pop in whenever they see fit. And this aerial drone was taken, and I'm going to walk through a whole series of these photos and highlight some of the things in what you're looking at. To start things off, flow is going from the bottom of the screen to the top. This is the Scott River, and this is Sugar Creek coming in from left to right. This photo was taken before we were completely finished with this feature back here, and I'll describe what that is. I guess I'll describe it right now. So this is what we refer to as the constructed terrace. And what the constructed terrace really is trying to do is concentrate flow to remain more towards river left. And this does two things. It touches on what Dustin mentioned about that the preceding, before project, there was a big island here, and this connection from the Scott right here to Sugar Creek right here was often disconnected, both from downstream and upstream. So the Sugar Creek was really isolated. So by building this constructed terrace, we're pinching off that river right channel. Engineering standpoint, trying to keep the conveyance about the same, especially when related to what we see upstream. And so that terrace tries to accomplish that. And inside the terrace is the point of diversion. This is the concrete structure where the water will now be diverted, and this is completely on Farmer's Ditch property, which helps the landowner here, the Callahan family. This is where that point of diversion was, and now it's squarely on Farmer's Ditch property. And although we won't talk about it much, an entire new access road was built to access the property, or the point of diversion, without going to the Callahan property. And Dustin's going to touch on some of the things that are planned for this point of diversion.
Yeah, I'm just going to go over this really quickly here. But so on the bottom right, we have a ISI cone screen, which will be installed into the concrete structure on the terrace. There's an automated flow valve, which requires a stream gauge in the river to basically tell the valve how much water is available and how much water is divertible. And that's all programmed into a SCADA RTU, a remote terminal unit. And yeah, it's an automated diversion based on in-stream flow conditions. So I think I'll just leave it there on that. And because we moved the diversion, we've also completely changed the physical constraints of diversion. So the previous diversion, it was subject to annual changes in the stream channel. The users were able to go out there and stack rocks to divert more water when needed. And then when you design a diversion structure, you don't really, it's a lot more, there are fewer constraints on your diversion from a physical standpoint. Those limitations aren't really there. So we had to come up with a set of diversion rules to, kind of approximate their historical ability to divert water while also providing, some baseline protections for fish. It's important to realize that, there's no like increase in water use efficiency associated with just doing a diversion. So, so we built in some diversion rules. There's a little bit of complexity here, but the basics are that they have a minimum bypass of 18 CFS that must be maintained to divert water, and they have a maximum percent of flow diversion of 40%. And so I've created a couple graphs here on the right that show the impacts of the diversion rules when compared to what they actually diverted in 2023. And I picked 2023 because it happens to be exactly the median year. So the dark blue line is the proposed diversion, and the orange line is the observed diversion. And one thing to point out here, especially on let's say from the 1st of June to the left, so April to June, they have water available that they're deciding not to take, presumably because there's enough there's enough water on their fields already from precipitation or just maybe shallow groundwater flow. So there are periods within their irrigation season that they will be capable of taking more water in some years, and then it's more of a steep drop off in their diversion rate when flows are dropping. So it's kind of targeting that dry season base flow condition of when we are providing the baseline protections. And so the graph on the bottom is actual stream flow observed stream flow compared to our proposed condition compared to the observed condition. And it's one thing to point out here is it's a log scale on this one. Otherwise, you really wouldn't be able to see what's going on. I'm not trying to manipulate the data or anything, but it shows that, in that early season, like April 1st through June 1st, there's enough water in the stream where you're not really going to notice that, 5 CFS change. And then you'll see there's a period where the observed bypass actually shows more flow in stream than the proposed right there. Yeah. And then as flows continue to drop, that trend switches and the proposed condition provides more in-stream flow than the observed. And that's kind of the goal here. And like I said, there's no inherent like water use efficiency improvements in this. It's just, trying to sort of mimic a extremely variable diversion based on physical constraints that no longer exist while maintaining some baseline protections. So I think that's all I have on that.
Great. Thanks, Dustin. And there's a lot that we're still working on to get this whole startup going, and that's what's happening currently. So moving downstream, we're going to talk about some of the other components, starting with the rough and channel. For those who probably aren't familiar with the rough and channel, basically we're coming in and rebuilding the channel steeper than the natural channel wants to be. And we do that for a few reasons here because of that incision happening, and also wanting to create stable hydraulic conditions for the point of diversion itself. And it also helps protect the groundwater system and habitat further upstream. Although we're in the tailings and flow is going subsurface, the disconnection upstream isn't as severe as it is downstream. So being able to control the grade and reduce that incision from moving further upstream, we're able to really help that water flow situation through the site and like I said, upstream. So what we're looking at here is about a 500-foot long by 150 foot wide rough-in channel. I won't get into the construction techniques, but the main objectives were to have flow under lower flow conditions, move past the point of diversion through this pool, and then migrate over through another pool and finally meet up with the Sugar Creek confluence pool. This will allow juveniles and adults, of course, to move from this pool up through the site and access everything further upstream, higher in the watershed. Again, improving that disconnection that used to be there. We have a secondary channel that flows on this side here. Things are fairly wet all the way across, but this is if this flow path has too high a velocity, there's another path for fish that meets depth criterion and velocity criterion to just offer some variability. And then as flows further come up, there's variability all over here. We're going to be monitoring that. But overall, because this is a rough-in channel is considered a hydraulic design, throughout the design process, we have to show through hydraulic modeling and other means that we will provide fish passage through a range of flows for both juvenile and adults. And you can see Sugar Creek comes in here, and then we have another secondary channel, which I'll talk about in a second. But here's a photograph standing about right here looking upstream. And although from the air you can see some of the cells and other things that were implemented to create sort of a more stable channel, from the ground it's much more challenging to see that. And you can see we've got a lot of good roughness. That's something that I really look for so that we create those variable flow conditions throughout the project area. And you can see the point of diversion structure there. Moving further downstream, we have a big floodplain that we simply lowered. The slope across it is a 1% slope this way. So as water comes out of the main stem, it'll flow across this and into the secondary channel. And the secondary channel is also connected to the confluence pool here. I envision a year from now, there's going to be a lot of willow and other things growing through here. This is one of the things about the Scott River that is kind of unique, although we've run into some things in other places. But we dug a 15-foot hole right here next to where the channel was, more or less, and it was dry that entire 15 feet. But we know that groundwater is moving off rapidly this way, and it's just stark how there can be groundwater in one place and none like a few feet away, or surface water right next to a dry hole. So yeah, that was one of the bigger challenges, and part of that we implemented. I came up with a horrible name, the river left treatment, but the idea here is the landowner, Caleb Callahan up here, during one of my sit downs with him, he's like, hey, the channel through here goes subsurface, like you can hear it percolating through. And we found out during construction, we put a block net so that we can isolate and remove fish from our work area. And one of our staff was pounding in a T-post, broke through, and about 2 CFS, cubic feet per second, was leaving through that hole. And you could see the turbidity appear in the pond, which is this pond back here. And it was just extremely well connected. And, you can see here the channel was going dry and probably all of it ending up in this pond and then moving further downstream through the tailings reach. So what the objective of this feature was to come in and try to get that thou egg being the lowest point on any cross section. So like where the flow goes. Oh boy, we're
Yeah,
Uh,
no technical terms, yeah.
and built an inset floodplain to try to just the boulder barbs and that inset floodplain being slightly higher than here will hopefully keep the thoweg away from this tailings and keep it wetted longer and that connection going.
So you're trying to keep that water from leaving out there if you can.
Correct. And as soon as we finished building it, this situation ended and it connected even in our, later in the season. I will go through these quickly so we can get to some questions.
Yeah, and then we can talk permitting too.
Yeah, I know. Poor Leslie.
Yeah.
We built, this is where that river right channel was. We came in and built a backwater alcove, loaded it with wood. And we lowered this floodplain approximately 6 feet. And there was a feature that was to be implemented. We've actually pushed it off till next year, but it's we refer to it as the hyperrate control structure, where we are going to build below the ground surface a soil bentonite slurry wall so that we minimize water trying to leave the surface water condition and flow into that subsurface and through the tailings that we described earlier. If nothing else, increase the flow path so that it's less likely to leave, and in some situations, maybe connect to bedrock. And this was to be a pilot study. And I'm just going to fly down. We're turning around. We're coming back upstream. Here's that alcove on the right, just to help orient you. And then we have Sugar Creek. Again, Sugar Creek, it's just important to note that this is one of the first projects I had where there was, impacts to something that was working really well. And one of the ways that we tried to remedy that impact was to take this roughened channel and extend it above where we could have stopped there, extend it up another chute and increase the water surface backwater condition to mimic what the BDAs were providing. And so far it seems successful. We're creating a backwater that's wetting up this floodplain and some of the other improvement projects that are located back here that have been completed by the Scott River Watershed Council. And lastly, to sort of make amends for some of that impact to those beaver dam analogs, which were providing important rearing habitat, we constructed a large alcove right off the channel, and it more than approximately doubled the surface area, and the depth is really variable and added a lot more water volume. And here's some simple photographs of what that looked like when we were done.
And it's cool to see it from above and on the ground. So yeah, giving fish, water in the creek, and places for them to go when there's high flows, and making sure there's water when there's lower flows, giving them, the wood and things to hide under, and habitat for baby fish too.
Yep.
A lot of different components.
And
Okay,
now
are we
we
ready
gotta
to talk
talk about-
permitting?
Yes.
So this is a lot. This is a lot in a project. So yeah, Leslie, what was about what the permitting process was like? Any efficient pathways you used, and how that went. And this is really the sustainable conservation connection to these kinds of projects is that we helped set up many of these permitting pathways. So yeah, Leslie, take it away.
Yeah. Okay. So, as is standard for most projects, we pursued federal, state, and local approvals for the project. Fortunately, we had, everybody was very aware of the project before it occurred. On a federal level, we had, of course, it's ownership and funding that can really influence what approvals you need to seek for a project. In this case, we didn't have full NEPA document. This was all done on private property, but we did need to pursue a permit from the U.S. Army Corps of Engineers. And so in that process, that also requires ESA compliance and compliance with Section 106 of the, I'm sorry, I'm getting over being sick, compliance with the National Historic Preservation Act. So we did develop our own biological assessment for the project that we submitted to NIMFS for impacts to fish. And then we also we received technical assistance from the U.S. Fish and Wildlife Service for impacts to fish that would be of federal concern. On the state level, There's streamlining pathways that have been developed by both CDFW, California Department of Fish and Wildlife, and the Water Board were fantastic. And we used two different streamlining tools. One developed by Cutting the Green Tape program, and sustainable conservation was probably involved in developing that pathway, along with the statewide restoration general order that was offered by the Water Board, which also afforded CEQA compliance because our project was consistent with the statewide restoration general orders programmatic environmental impact report. So I was very thankful that we could rely on that programmatic CEQA coverage. And then the streamlining tools, the permitting tools provided by CDFW through what's called a restoration management permit, and then the permitting through the statewide restoration general order through the Water Board allowed us to get through the permitting process, pretty quickly. So go ahead and move to the next slide, Travis. And, a couple of the challenges that we had out here. Here are some of the activities that I'll get to in a minute, but a couple of the challenges that we had were a very compressed timeline for getting through the environmental compliance process because design had many different considerations. We had a lot of stakeholders that came from a lot of different angles. And, the good thing about that, about considering those diverse stakeholders is, just considering them, really trying to implement consider what their concerns are about the project. But it did take a while to get through the design process. And so we got to a pretty compressed timeline. But we did have NOAA NIMS, and CDFW in particular really involved a lot in the design conversations. And by virtue of that involvement, they knew what was coming in terms of our environmental compliance requests. So we had a lot of fish relocation that was required on site. Like Dustin mentioned a little while ago, this is really a stronghold for coho. We ended up capturing and relocating over 7,500 coho. We had a lot of steelhead as well. We had lamprey. Previous slide showed a Pacific giant salamander. So the fish capture and relocation was more time consuming than anybody could have anticipated this year, but it was a very unusual year. So both the federal and the state agencies were very supportive of the unanticipated circumstances that were present on site. And we had a lot of on-the-ground support, in particular from CDFW, both for e-fishing and seining. So we weren't strictly capturing fish via e-fishing. We were doing a lot of seining and capturing aquatic species by hand. So you can go to the next slide. And here we go. A couple of examples. There's coho on the left, lamprey on the right. These two different permitting pathways that I mentioned before, cutting the green tape, I cannot say just how beneficial that was because the restoration management permit combined several different, rather than having to pursue a tape permit with the state and a 1,600 for stream bed alteration, we were able to combine those requests into one request of CDFW through the restoration management permit. And then with this statewide restoration general order, or SRGO, that too we were able to navigate both CEQA compliance and our permitting through that one avenue. And I am zipping through this just to try to leave a couple minutes for questions. But if anybody, if anybody has questions, you can reach out to me directly if you have questions about like what was the whole package of permitting, how did we do?
Yeah. And we've got I'll plug to we've got a blog about on the Sustainable Conservation website. And then for the people who really want to, and I'll put that in the chat, and for the people who really want to dig into the permitting details, we are working on a page for the Accelerating Restoration website about this project. I've got all sorts of questions for Leslie to answer, provide her thoughts to really dig in the details of this permitting stuff for the people that are really wanting to know more about the technical details.
Sure. Well, it's a challenge, and I would say, you just try not to put the agencies in the hot seat and try to push something through in like rapid order. But we did put them in that position on this and tried to do as much of the heavy lifting as we could on our own. But it was just because the streamlining tools were developed as well as they were that we were able to get through it. So early planning, for us, I think what we found was to make environmental compliance go well, the communication is critical, and then making sure you have some type of flexibility built in to how you write your permit. I mean, you want to try to be as succinct as possible, but we site conditions really indicated that we would be able to do things a certain way on site. And then once we tried to do them that way during construction, we found that that wasn't the case at all. So, we had to have room to wiggle. And
Yeah.
So we tried to put that, that was a learning lesson for sure. And the state agencies were great, as well as the federal agencies were great about, our initial take level for coho was like 971 coho, juvenile coho. And we captured over 7,500. So, that
Yeah.
we
That's a
had
big
to do a
difference.
major adjustment. And so, I'm just saying,
Yeah.
collaboration with your project partners and your agencies is very, very important. So
Yeah.
I'll
Yeah.
cut right there for a couple minutes of questions. But like I said, if anybody has questions, you can reach out.
Yeah. And someone's asking if this is going to be recorded. Yes, and we'll also put this will get sent out, and we'll also put the recording within that blog. And yeah, that's definitely Leslie. It's like you're not in control of how many fish are coming up the river. They're going to do what they're going to do, and you have to be able to adjust. Working in natural systems, things happen. All sorts of things change. Let's see, we have just a couple minutes. I know there's definitely people who want to know if the beavers are still in Sugar Creek, how are they doing? Um, let's
So,
see some
Yeah.
other questions.
so
Yeah.
about the beavers, so what we were
Yeah.
looking at there were beaver dam analogs, so they're man-made beaver dam structures. We didn't actually note any
Hmm.
living beaver in the project area, unfortunately. Maybe they'll
Yeah, and
show up now.
Maybe someday.
I believe they're upstream of Highway 3, so upstream on Sugar Creek, but not in our footprint, not currently.
Yeah. So maybe someday there will be beavers in there, but not yet. Let's see. Any other let's see. I'm trying to look for some questions. Let's see. And then I guess also, just if you want to talk about, what's in our limited time next, we kind of got the what's next question. And then there's also kind of like stepping back, about how you apply this collaborative approach to other projects. So whatever you think you could answer in the next couple minutes, or would like to answer.
Yeah, I can try to touch on what's next. It's a little fuzzy. We're meeting with a whole bunch of partners tomorrow to talk about more or less this purple footprint. This orange is more or less where we were this year, and talk about, we're meeting with the Watershed Council, with Morris Gravel, and other landowners, and then myself, Dustin. Anyway, we're trying to figure out what's next, but this has been a great way to create some momentum. Most of our permits, Leslie, correct me if I'm wrong, are ready to go for next year, or maybe just need a little bit of update to include next year's footprints and things. But there's a lot to hopefully report on in the next few months, because there is anticipation of further construction next summer, likely removing more of the tailings and just giving the river more room to breathe. But that exact footprint is still to be determined.
And then
You
there's,
know,
oh, go ahead, Leslie.
So I was just going to say, Travis, I think it's worth mentioning also, we're really on the hook for quite a bit of monitoring of this site as well. And, I started making a list of all of our monitoring commitments, but fish passage and performance monitoring, of course, we'll submit, and we'll prepare an as-built survey. We're doing photo point monitoring to identify revegetation success after we go through our re-veg process. There is salmonid habitat and utilization. We're considering doing dive surveys, spawning ground surveys. There's surface water flow and water quality monitoring. So flow monitoring, water temperature and dissolved oxygen, groundwater monitoring. So a lot of monitoring is required because we're really hoping to use this project to learn a lot about what works and what doesn't work within the tailings reach.
Mm-hmm.
Big goal.
Yeah. Yeah, thanks for mentioning that. Because yeah, the learnings are really important from these projects. Let's see, any other last comments from the group to wrap up before I do my wrap up?
I see the one question about how long construction was. I think it's good to mention, you know, it was great to work with all the agencies and get all the permits in place. Leslie and her team did an amazing job. Through all that, we didn't actually hit the ground until July 28th. So we were out of the active channel on Friday, October 31st. So it was fast and furious to get everything done.
Yeah, and any final thoughts from about kind of the the collaborative approach on this project?
I guess I'll kick it off real quick and then let others chime in. The main takeaway from me is, engage often. Don't go into your little design bubble and come out and say, here's what we're going to do. Engage with as many groups as you can. Be willing to concede some things that you really want just to have, meet other people's objectives and recognize that there's going to be trade-offs that, hopefully you end up with a project that everyone can be behind, even if there's parts they don't like about
Anything
Yeah,
else to add before we go? Yeah, Dustin.
I'll just add that it's really important to meet people. I hear this phrase in politics all the time, but meet people where they are. Like, whether it's in a barn, or in a freezing pile of rocks out in the Scott River, it's important to get out there and actually face to face, try to understand their real concerns and move forward with that in mind.
Yeah, thanks. And also spend time with their dogs. I see. That's important.
Yeah, very important.
With the pets. So yeah, I mean, I know we couldn't get to everyone's questions. It's a fascinating and complex project. I'm sure you could talk about it for hours, if you went into every detail of it. But a big thank you to Dustin, Leslie, and Travis for joining us today and sharing your knowledge and experience. And we really appreciate you taking the time. And thanks for all of you who tuned in. We hope you enjoyed the conversation. We'll be sending this out in case you missed anything or want to revisit the discussion. Like I said, check out that blog as well. And then this is the last webinar in our fall series, but if you want to hear more about, this project and some others, Leslie and others will be, there's going to be a California Natural Resources Agency webinar on December 16th. It's going to provide an overview of the Cutting Green Tape Initiative and restoration permitting tools for a tribal audience. So they'll be talking about this project and some others and permitting pathways. So if that's of interest to you or others, I put the link in the chat. And there's more webinars in that series being planned. So I'll put the link. We can sign up for emails from the Resources Agency about those. And if you'd like to follow Sustainable Conservation's work, Hannah's going to queue up, there we go, on the screen here. And thank you all for tuning in again, and many thanks to our great panelists. Bye.
Thank you, Stephanie, and everyone.
Thank you, Stephanie.
Thank you.
Everybody.
Thank you all.